Assalamu alaikum, welcome back. Here we try to explain the genetic algorithm steps by using an example. All right, so first step of genetic algorithm is to the first step, which is here, try to represent the problem variables domain as a chromosome of a fixed length, choosing the size of the chromosome of the population, and also to choose the size of the chromosomes, okay? So as well as to select the probability to do crossover as well as to probability to do mutation. So here in this problem, now we have in the first step, we have this problem, which is here I have this equation 15x minus x squared. So I have the values of x is between 1 to 15. So in this problem, I try to find the maximum f of x and which value of x that can produce the maximum value of these fitness functions. Okay, so here this is my problem, try to find the maximum value. So here my problem, try to find the maximum. Some other problems, try to find the minimum or try to find the best values. So the variables here we have x, it range between 1 to 15. So how can I represent it as a chromosome? So you can see that here the chromosome can be represented as a binary code, which is 0, 1. So here from 1 to 15, so I have 4 bits here. So I will have 4 binary numbers, which is 4 bits. We'll take the value 0 or 1. So each chromosome can represent as 4 binaries. Okay, so the size of each chromosome, 4 binaries. And now here I try to initialize, as I said here, 4 genes for each chromosome. For example, 1010, this is 1 chromosome. And then here we try to initialize or try to give value for the population. For genetic algorithm, you have to suggest some solutions or some examples or some variables. Okay, so here there is, you create an array in your code that contains the proposed solutions. So here in this example, we create only 6. Maybe in your case, you can create 10, 100, or whatever the size of your array. So later it will be depends on your time, depends on the problem. So the processing times, then you can select the size of the population. So how many solutions you are going to generate in this array. So here we initialize by 6. So I will create 6 chromosomes. These 6 chromosomes represent 6 variables. Here I have here 1 to 15. In real life, maybe you have a range of data between in negative infinity to positive infinity. You try to find what is the best value. So here in this example, it is only 15, but in real life, you have a huge number of variables. So you cannot imagine how long it will take to find the best. Even it's impossible to select the best value. And also this objective function is very simple one, which is only one variable. Some other problems, it has multi-dimension, which is have x1 and x2 and x3, and you have parameter 1, parameter 2, parameter maybe several number of parameters. So you'll have several chromosomes, not only one chromosome in one solution. In one solution contains chromosome 1, and in the chromosome 1 will have several values of x. x1 is here and chromosome 2 is here. I mean chromosome 1, variable 2, variable 3. So many variables. That's another problem, which is multi-dimension. Here only one dimension, which is only one x. As well as here, after I initialize the size of population with 6, of course here it will be empty until now. I don't initialize yet. I'm in this step. Just give the size of the array. I have 6 chromosomes. Then also I have to give a probability. If I want to make a crossover, what is the value? The value of probability to do crossover between 0 to 1. It's a real number. It's a real value. It's a real number. which is between 0 to 1. Here, if we give 0.7, as shown in the example, 0.7 means I will have chance to do crossover 70% to do crossover, okay? As well as for probability to do mutation. In this example, we give 0.001. It means 1%, means it will be very take maybe long time to do mutations, or maybe rare. It's not always you are going to do mutation because here you introduce a new solutions, or to introduce modify in the chromosome, which is global search here. Then after we initialize all these parameters, the population size, the size of the chromosome, the probability to do crossover, the probability to do mutation. And then step 2. And in step 2, we start define the fitness function. Here, what is the fitness function? We try to identify, to define it. The fitness function will be f of x, f of chromosome will be 15 of that chromosome minus the chromosome to the power 2. So I'll try for x1, x2, x3, x6. I will have a fitness function for x1, fitness function for x2, fitness function for x3. So here I identify what is the fitness function. This is the fitness function. Then based on this fitness function, I try to calculate for each chromosome. For time being, I just initialize the size. I don't have any chromosomes yet. So we'll move to the step. As I see it here, we're selecting the chromosome that will be mated during the reproduction. So here, based on these fitness functions, the values we are going to do crossover or mutation based on the values here. So if we move to step number 3, which is randomly generate an initial population of chromosome in that when n is 6, so I have array of 6. Now I try to generate these chromosomes randomly. Mean I have 4 genes, 4 binaries, so it will get the value 0, 1, 0, 1. So here randomly selected these values. Then I'll try to identify what are the values of this, okay, this chromosome. So this binary represent x1 is 12, and this binary 0, 1, 0, 0 represent x2 as 4, and for chromosome 3 represent variable number 3, which is represent 1. And here 14 for variable number 4, x4, and x5 is 7, x6 is 9, which is represent this number, okay? Which is here in step 3. In step 4, try to calculate the fitness functions for each. So here I have this variable, which is 12. So the fitness function of 12, f of 12 equal 15 to the power 15 times 12 minus 12 to the power of 2. So the values of fitness function is 36 here. As well as for each variable, I'll try to find, or for each value, I'll try to find the fitness function for that chromosome. Okay, so here I got this objective functions values, or fitness functions. Sometimes we call them objective function or fitness function, which is f of x1, f of x1, which is x1 here is 12, it will be 36, and f of xn, which is I have only 6, f of x6, so here f of 9, it will be 54. Then here we have step number 5. Select a pair chromosome for mating, or for to cross over, to change the values, to improve. So here just initialize. Now in step 5, step 6, it's called here improvising the suggested solutions. Here I have these suggested solutions. Now I try to improve these solutions. This is my first run, which is first round. It will be generate this. So here I have to select, I have to create another n population for new solutions. Okay, so I will have here. So to do crossover, I have to select new. First, I have to select new, new population, new n, maybe we call it n bar. So it will contain of new solutions. So here I have to select, then I will have here the variables and here the fitness function. So I'll have 1, 2, 3, 4, 5, and 6 solutions. So here I will create a new, this is x, this one new bar, this is prime, x2 prime, x3 prime, x0, x4 prime, and x5 prime, and x6 prime. So here the values will be generated, and then here the fitness function for each parameters. So here is the value of x. So here how to select, I have to create this new population. The size of the new population should be same size as the current population. Okay, so the first round, how can I select from these solutions to improve these solutions to be added in this array? We have a different approach to be used in this. Here we have like a roulette, we have a roulette, or we have a tournament, we have also select randomly. All right, we come back again. So here in this example, we will use like a roulette to have to help us to select the candidate to be improved or the solution to be improved. So how to create the ratio of each solution? So like here, the total here, each solution have a result, have a amount. So how to calculate the ratio of each of these solution? Let's first you have to add all the solutions to sum all